So, hello, dear viewers. Good morning, all of you. Let's welcome to my channel Knowledge for You. Today, I am making this video from 5th unit of Diploma subject Digital Electronics, that is flip flops and registers. The intention of making this video is to make you get 14 marks in your end semester examination, and these are the questions from part A from 5th unit. I hope everyone will go through it and try to memorize all these questions. So make a note of it so that it will be useful for you to score 14 marks. So 14 marks is the criteria to pass in your end semester examination. That's the intention behind making this video. And not only this, even these questions are helpful for interview point of view also, those who are preparing for digital electronics subject. So let's start our video. Define sequential logic circuit is the first question. So a sequential logic circuit is a digital circuit whose output depends on present input as well as past inputs. So it is a digital circuit whose output depends on present input as well as the past inputs. Okay, so to store the past inputs, it must have memory. So in short, I am writing it as like this. Output is function of present as well as the past inputs. Present as well as the past inputs. So do remember, to store the past values or previous values, it must have memory and feedback. So these are the 2 points also you can include if you get this question for 3 marks. And one more question related to this, you can get difference between combinational circuit and sequential circuit. So in combinational circuit, the output depends only on present input, whereas in sequential circuit, the output depends not only on present but as well as the past inputs. Second point, to store the previous values, definitely it must have memory. So that will be there in sequential circuit, whereas memory is not present in combinational circuit. Feedback is present in sequential circuit. Feedback is not present in combinational circuits. So you can prepare the 2 questions from this. That is difference between combinational and sequential also. So let's go for the second question, define clock. I don't want to waste much of your time. I want to make you the answers very precise in nature. Second question is define clock. A clock is a periodic square wave signal which is used to synchronize operations in sequential circuits. It is a periodic square wave signal used to synchronize operations in sequential circuit. So it is a periodic signal. You can write, it's a rectangular pulse train also you can write. So this is nothing but our clock signal. So it is a periodic square wave signal used to synchronize the operations in sequential circuits. Next question we have, state the necessity of clock signal. So why do we use clock in sequential circuit? Then the answer is, it is necessary to control the timing of operations, to coordinate the data transfers, and ensures flip-flop change states only at specific instants. That is, in clock, the next question also arises from this. What are the types of triggering we have? There are 2 types of triggering. Edge triggering and level triggering. Edge triggering and level triggering. In edge triggering, again we have 2 types, positive edge and negative edge. So this is the positive edge triggering. The rising edge of the clock pulse is called positive edge and the falling edge of the clock pulse is called negative edge. So triggering is of 2 types. One is edge triggering and the next one is level triggering. In edge we have 2 types, positive and negative. In level also we have 2 types, positive and negative level triggering. So do remember, this is also one of the important questions. So I am giving all the important questions from the 5th unit that comes from part A. Next we have define preset and clear inputs. Define preset and clear inputs. One more question that arises from this question is, what are asynchronous inputs? What are asynchronous inputs? Then the answer is, preset and clear are called as asynchronous inputs. And the next question comes from this is, what are synchronous inputs? So we have 2 types of questions you can expect from this. What are synchronous inputs and what are asynchronous inputs? Synchronous inputs means JK input, D input, T input and SR inputs. These 4 are called as synchronous inputs, and the other category we have asynchronous inputs. Preset and clear are called as asynchronous inputs. The next question is, so what is the definition of preset and clear? Preset means making the output to 1. making the output to 1 regardless of other inputs. Okay, so it is a control input that sets the flip-flop output to 1 regardless of the input, or simply in other words you can write it makes the output 1 regardless of other inputs. Okay, it makes the output 1 regardless of the other inputs. Next we have clear. Clear is also known as reset. So simply you can write it is a control input that makes the output to 0, that forces the output to 0. And these two are independent of clock signal. These two are independent of clock signal. So next question we have, what is race around condition? What is race around condition in JK flip-flop? What is race around condition in JK flip-flop? So race around condition means toggling more than once during a single clock pulse. Toggling more than once during a single clock pulse when j is equals to k is equals to 1 and clock pulse is high is known as race around condition. Is known as race around condition. Toggling more than once during a single clock pulse. So see here, coming to this, what is toggling more than once during a single clock pulse? If it is my clock pulse, so within this one clock pulse, if the output toggles more than 1, that is 1 0 1 0 1 0. So here we don't predict the output. The output is unpredictable during a single clock pulse is called race around condition. Usually this condition occurs when j input and k input are 1 and when clock pulse is high. So this is very important one. So you can expect such kind of questions even in your ESET also. When clock pulse is 1 and j equals to k equals to 1, that condition is known as race around condition. Okay, toggling more than once during a single clock pulse is called race around condition. And the next question is, how can we avoid this race around condition? State the methods of reducing the race around condition in JK flip-flop. And the answer is use of master slave JK flip-flop, use edge triggered flip-flop, and keep clock pulse width small. So this is the answer. Okay, so we have 3 methods to avoid the race around condition by using master slave JK flip-flop. Next, edge triggered JK flip-flop, and keep the clock pulse width very small. This is nothing but clock pulse width, so this should be made very small. Next we have list any 2 commonly used IC numbers of the following flip-flops. First one we have clocked SR flip-flop. So do remember all these ICs, they start with 74 series. And 74 series belongs to TTL logic family. It belongs to what? TTL logic family, transistor logic family. So if the question comes, write the TTL IC numbers, then in such case also you can write down these IC numbers. So for clocked SR flip-flop, the IC number is 7400, 7474. See here, the starting 4 digits, they are from 74 only. Next we have edge triggered JK flip-flop. It is also 7476, 74107. Master slave JK flip-flop 7470, 7472. If we add 2 to this, we get 7472. Level clocked D flip-flop 7474, 7475. Continuation. Level clocked T flip-flop 74107 and 7476. All are 74 series. So do remember these ICs. Definitely you can expect one of the question from this for 1 mark. Write down the IC number of these flip-flops. And next we have define register. Define registers. So a register is a group of flip-flops used to store multiple bits of data temporarily. So register nothing but it is a group of flip-flop which is used to store multiple bits of data temporarily. And the immediate question you can also expect, what is the need of register? Register is used to store the data temporarily. The first point is it stores the data temporarily, and the second one, it shifts the data. Okay. The next question also gets, what is flip-flop? What is flip-flop? So flip-flop is a bistable device. It stores 1 bit of information. This is the answer you have to write. What is flip-flop? It is a bistable device. It stores 1 bit of information. That's the definition of flip-flop we have. And the next one we have, state the types of registers. Then the answer is SISO, CISO, CPO, PISO, PIPO. CISO means serial in serial out shift register. CPO means serial in parallel out shift register. Parallel in serial out shift register. And PIPO means parallel in parallel out shift register. And the next one is universal shift register. Next, list any 2 commonly used IC numbers of register. Then the answer is 74. See here, all these are start from 74 only. 74164, 7495, 74165. 164 is SIPO, serial in parallel out, and 165 is PISO, parallel in serial out, and 7495 is universal shift register. So I'm not making the video very lengthy because as per research, it's concluded that a student can't pay attention more than 10 to 15 minutes, their attention gets deviates. So let's wind up my video with this only. Thank you all of you for paying the attention, and please go through this video to get 14 marks to get pass in your diploma. Thank you once again.